Okay, so in my presentation today, I will be talking about the von Neumann architecture and the kind of pros and cons between it and different types of architectures, namely the Harvard, I think, right? So the von Neumann architecture is it's kind of simple in a beautiful way. It's a processing unit that contains arithmetic, logic, unit as well as processor registers. Has a control unit that contains an instruction register and program counter, and the memory that stores data and also the instructions. And has an external mass storage, input and output mechanisms, the kind of standard stuff. I meant to start on this slide, but whatever. I feel like that kind of works in as well. The history of this von Neumann model is that it was actually, I thought this was kind of interesting, and I think there's a little bit of debate on kind of who actually found it and who came up with it, at least from whatever I was able to find. But it's based on just a architecture design description in a 1945 issue of a first draft of a report on the EDVAC, and I forgot to remember. The von Neumann architecture is nowadays essentially synonymous with any stored program computer, where any instruction fetch and data operation cannot occur at the same time. Because it's all kind of shared on a common bus, which is why it's simple in a great way. It's easy to implement, but it is limited, and we'll talk a bit more about that now, moving into the the pros and the cons of the von Neumann architecture. The pros are that it is simpler, as I mentioned a little earlier, than the Harvard architecture machine, as well as other types of these architectures. It actually requires less physical space than the Harvard architecture. Some of that comes from the bus, the singular bus that shares everything. Also, having to deal with only one memory block is simpler and easier to achieve, and as you'll see that it comes with its flaws and its issues, but it is definitely a benefit when it comes to quickly implementing, or if you have a simple issue or problem that you need to deal with. You don't need to pull in a full Harvard architecture. You can just kind of implement a von Neumann. And it's also cheaper than the Harvard architecture, which comes with the same benefits as the other kind of stuff discussed above. It's cheaper, it's smaller, it's quicker to implement. It's a great down and dirty implementation. But all of this comes with cons, which certainly does have cons. Due to shared memory, it's possible to overwrite another memory. If you have a defective program, which can be, pretty rough, can cause crashes. System can have memory leaks also that fail to release memory when they're finished using it. This also can cause crashes, as you can imagine. There's also what's called the von Neumann bottleneck, where the data bus is much slower than the CPU. So the CPU is often sitting idle instead of being utilized. And both data structures are shared on the same data bus because data and the instructions have different fetch speeds. The system can lag due to that. But that's a quick rundown of what the von Neumann architecture is, as well as its pros and cons. And I hope you guys enjoyed it.